Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. Within this module, we are trying to understand how the operating system manages the CPU via the concept or abstraction of a process, right? So within this module of process management, we are currently on the first topic, that is process introduction. So here, through a series of videos, we are trying to understand what is a process and how the operating system implements this abstraction of a process in the computer system. So till now, we have understood what is a process. It's a running program. And in the previous video, we have also seen the difference between the program and a process. So now we have a good understanding of what is a program and what is a process. So in this video, what we are going to do, we are going to discuss how when you launch a program, it becomes a process. Basically, we want to try to understand the journey of a program to a process. So without further ado, let's get started. So if you have watched the previous two videos, then you know that a process is a running program, right? So what we have to do to get a process? First of all, we as a user have to launch a program, right? This is the first part, that is the user launching the program. And then there is the second part where the operating system will do certain things to build this abstraction of a process for the program that was just launched, right? So this journey of a program to a process, there are two parts to it. One, from the perspective of the user who is launching the program, and the other is from the perspective of the operating system, which will do certain things to create a process out of that program, right? So we are going to see this journey both from the perspective of the user who is launching the program, and then from the perspective of the operating system who creates a process out of that program. So let us first of all see this journey of a program to a process from the computer user's perspective. So this slide summarizes the journey of a program to a process from the perspective of the computer user. So as we know that a process is a running program, and as far as the user is concerned, getting from a program to a process is fairly simple. They just have to launch a program, right? And in the first module of this course, that is the introduction module, we have already studied about the user interface, which allows the user to launch programs. So there are two major types of user interface softwares. One is the graphical user interface or the GUI, and the other is command line interface or the CLI. So from the perspective of the user, they have to launch a program, right? That is all they have to do, and it's the operating system which will take care of the rest. And how can they launch programs? There are two ways, as we just said. If they're using the graphical user interface, then in that there is a desktop, and this desktop has several icons. Each icon represents a computer application, right? So whenever the user wants to launch any particular computer application, they can double click on that icon, and then the GUI software will launch that. Will first of all figure out which program that the user wants to launch and locate the executable file for that program, and then supply that to the operating system along with the relevant arguments. It will request the operating system to create a process out of that program, right? So this is how the journey looks like when the user is using the GUI. The other option that the user has is that they can launch a program via the command line terminal or the CLI. So it has a command interpreter, something like this. It has a command prompt. The interpreter has a command prompt which waits for the command from the user. So here the user can give their command or the path to the executable file that they want to launch, and they can also supply the relevant flags and arguments. The command interpreter will parse those commands and figure out the location of the executable file, just like in the case of the GUI. Once the executable file has been located, it then in a similar way raises a request to the operating system that this is the program that the user wants to launch. These are the arguments. Please create a process out of it, right? So you can see the user interface software acts as an intermediary between the computer user and the operating system. The computer user will be giving their commands via the CLI or the GUI. That is, they want basically convey their intent that they want to launch a program, and these user interface software then will route these requests to the operating system, and from there the operating system creates a process out of it. So this was the journey from a program to a process from the user's perspective. Let us now look at what all the operating system does whenever it receives such a request. So there is a whole bunch of things that the operating system has to do in order to create a process out of that program. So let us understand that part. So there are a bunch of things that the operating system has to do whenever it receives a request to launch a program, right? So let us understand what are the operations or actions that the operating system takes when it receives such a request. So to explain that, let me take a hypothetical example. This is a computer system, and on the disk we have a simple program. It's a executable file, hello.exe. It was generated after compiling this source code. So you can see there was a simple source code that is hello world, and it was compiled to get this hello.exe executable file. So this is the program. It has the instructions and data corresponding to this source code, and it is in binary format. It's a file containing the instructions and data, and now it is residing on the disk. It's just a file. So now let's say the user of the computer conveys their intention that they want to launch this program. So we just saw that they can do that either via the CLI or the GUI. So when the user conveys their intention or initiates a request to launch a program, then the user interface software will request the operating system to do the same. So now we saw that the user interface software will also supply the location of the executable file. So now the operating system knows where the executable file resides, which the user wants to launch. So the next thing that the operating system has to do, it has to load this executable file into the memory. Why? Because uh, if you recall the von Neumann model, then when the CPU has to execute the instructions and data, those instructions and data have to be present in the memory. The CPU cannot directly like perform the processing or the execution on the disk. So as you can see, the first thing the operating system does when it comes to launching a program is that it reads the program file and loads the code and data for the process into the memory. And this region which stores the code and data for the process is also called the process address space. So we have already studied the concept of an address space in the first module of this course, the introduction module. So an address space is basically an abstraction that the operating system creates on top of the memory in order to make it easy and efficient, in order to make it easy to use, first of all, right? So what the operating system does is that for every process it provides the illusion of a private and a very large memory, and that it does by the concept of an address space. So what does the address space contain? It contains all the code and data of the process, right? That is all there is in this address space, the instructions as well as the data. Now once the code and data for the process are present in the address space, then the CPU can begin the execution. But before we get to that part, let me also explain how the address space is divided into different sections. So the operating system organizes the code and data in a certain fashion, in a certain layout in the address space. And as you can see, there are majorly 4 different sections in the address space. So we'll study about address space, the sections of the address space in great detail in the next topic. But for now, in brief, we can understand that there are 4 major sections. This section, that is the code section, contains the instructions of the program. So as we know that the program contains 2 major things, the data and the instructions. So all those instructions that will be executed are put into this code section. This is how the operating system is organizing the code and data in a certain layout, in a certain fashion, by putting certain like instructions or data in certain sections. Then after putting the code, then comes the data. So there are different types of data. So here, all the data that was statically generated when you compile the program, all of that is loaded into this data section, right? And so there will also be certain types of data that will be allocated by the process when it is running. So there are 2 types of data. One that is generated after compilation, that is static data, right? And one that the process allocates when it is executing during the runtime. So all the data that has already been generated before the process starts running is put into this data section, and the data that will be used by the process during the runtime, that those memory, for those memory allocations, there is a pool of memory that is called the heap. From this pool of memory, the process can make dynamic memory allocations on the fly. And then there is this memory region called the stack section. On the stack section, the execution of the functions take place. So any piece of code that you write contains several different functions, right? And any execution that happens inside a function. So you can think of the execution of your code as a series of, as an execution of a series of function calls, right? So all of those function calls have to be executed in a certain way. So the stack memory is a region that is dedicated for this purpose, that is to track and execute the functions. So this was a brief description of what are the different sections that are there in the address space, how the operating system organizes the code and data of your process in the address space that is present in the memory. So the point is that first of all, you have the code, the source code, you compile it and get the program. This program has your instructions and data, and it initially resides on the disk. And when the user wants to launch that program, the operating system loads the code and data that is present in this program into the memory. And this region in memory where all the code and data of the process lives is called the process address space, right? and it is organized into different sections, and each section has its own purpose. Some store instructions, some store static data, and some are dedicated for dynamic memory allocations. The stack is for the execution of functions. So these are the different memory regions that are there in the address space, and they serve different purposes. So now that you understand how the code and data has been organized in the memory, let us now see what else the operating system does after loading the program in the memory. So once the operating system has loaded the program into the memory, it has done the memory setup. The next thing that it does is that it will do some setup for IO devices. So input and output is something that all the processes will do, right? They will be interacting with the user. They will be taking the input from the user and then producing output for the user. So input and output is common to all the processes, no matter what exactly they are doing internally, right? So what the operating system does, so I'm speaking in the context of Unix based operating system. What Unix based operating systems do is that they set up the some IO devices for all the processes at the time of creation, right? So in the Unix operating system, the keyboard is considered as the standard input. So it is the keyboard from where the process will be expecting its input, the characters to be coming from. So the keyboard is the standard input device, and similarly the display or the console is considered as the standard output device in Unix based operating system. So all of the output that the process will be producing, that is considered to be destined for the display or the console. That is why it's considered as a standard output. So although it's not the case that the input and output will be coming or going to only these devices, but it is considered as a standard input, right? Or standard output. So what the Unix based operating system do, so the bare minimum thing that they do is that they connect the process with these IO devices. That is what is IO device handle. Basically, using these handles, the process can communicate with the standard input or standard output device. So this basic setup the operating system does for all the processes. If the process wants to use or communicate with more of the IO devices, they can do it later when they are running. But at the time of creation, this is the basic setup that the operating system does for the process. That is, it sets up some basic IO devices that would be essential or crucial for all the processes. So this was the setup related to the IO devices. After the memory setup has been done and the IO devices have also been set up, the process is almost ready to run. So now what the operating system does is that it has to set up some registers in the CPU. So as we know from the operating system's perspective, the CPU is a set of registers, right? It is oblivious to the execution circuit. It only sees some registers. So some of the important registers that are there are the program counter and the stack pointer. So the program counter stores the address of the next instruction that has to be executed. So if we want to start the execution of our program, then we have to put the value of the first instruction of our program in the program counter. So that is what the operating system does. And not just the program counter, it also sets up the stack pointer. So stack pointer is very crucial for the execution of functions. So as we know, there is a dedicated region in the memory, that is the stack, where the execution of functions take place. And what happens is that for every function that is there in your code, there is a object pushed onto the stack. So whenever there's a function call, an object that is called stack frame is pushed onto the stack, and whenever that function finishes, that is popped out. So the stack pointer keeps track of where or in which function is the execution currently going on. So don't worry if you don't really understand how the stack works. We will talk about this in great detail in the next topic. But for now, the point is that there are certain registers which are very important for tracking the execution of the program. One is the program counter, which points to the current instruction, and the stack pointer, which points to the top of stack where the execution of the functions take place. So in order to get your program running, so the operating system programs these two registers. Many other registers will also be there, but essentially these two are important ones. So the address of the first instruction of your program and then the stack pointer, all of these are set up, and now your program is ready to run. So whenever the CPU will be assigned to your process next, then the process can start running. So initially when the process is created, it is not directly assigned the CPU. So there might be some other process that is running on the CPU, but nonetheless, at some point in time, the CPU, the control of the CPU will be given to your process that you just launched. And at that time, when it starts running, since the program counter points to the first instruction, it will start running from the beginning, right? So this is how a program is launched and how the program starts running, how it becomes a process. So I talked about several aspects that are related to a process. First of all, I talked about the memory setup, that is loading the program into the memory. Then I talked about IO devices setup, and finally how the operating system sets up the registers in the CPU. Now, a very important point is that these steps that I discussed, these are not the only steps that will happen when a program is being launched. There could be several other steps depending on the operating system. These steps that I talked about is just to give you a basic idea of what are the things that the operating system does. It is not an exhaustive list of steps, right? So it's just to give you a basic idea of what happens when you launch a program and what are the things that the operating system does in order to launch that program, right? So it has to do a whole bunch of setup, mostly related to the different pieces of computer hardware, the memory, the IO devices, the CPU. So these are the hardware resources that the process will be using when it is running. So when the program is being launched and a process is being created, these are the things that the operating system has to properly set up, and then the process can start running. So you see how the journey looks like from the from program to a process from the perspective of the operating system. So guys, this was it for this video. In this video, we discussed how a program becomes a process. We talked about how it appears from the user's perspective, where they just have to launch the program. And then we saw in detail what are the bunch of things that the operating system has to do. So we saw the journey from the operating system's perspective. So there are several setup that the operating system does when it is launching a program. It sets up the different pieces of computer hardware, and then the process can start running, right? So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.